Welcome back to Tenant Codes. Today we're going to take a look at how we can use Golang to programmatically work with Ethereum blocks and the transactions within them. With that being said, let's jump straight into the video. So we're going to pick up the code exactly where we left it off. We are going to delete a lot of the code. Let's go ahead and delete the address checks and let's keep the client connection as we will need that. We won't need the address conversion as well as the smart contract check here. That will mean we won't need the common import as well as the regular expression, and let's keep everything else as is. Alright, so let's go ahead and take a look at how we can use our connection to an Ethereum node to get the header of a block. Let's go ahead and say client.header by number. Let's go ahead and pass it a context.background. And the second parameter is going to be the number of the block that we want to get the header for. Let's just say nil, which will return to us the latest block. Let's go ahead and set the value that is returned to the variable header and the possible error that we may encounter. And let's do our standard error check. Say if error does not equal nil. We'll say log.fatal and we'll say unable to get header. And then we'll go ahead and just say fmt.print, and then we'll say fmt.println to print the header that we just received. And then I forgot parentheses here, and we'll be good. Let's go ahead and head over to our terminal and say and go run main go. And you'll see that we are returned with a lot of data, and this is going to be the header of the block or the latest block. We can take this a step further and say .number and say string, and it's just going to return the string format of the block number. It just needs to be in quotations. So let's go ahead and run that, and you'll see that we are returned the current block number. Alright, so let's say we want to go ahead and query for a specific block using its number. We do that by declaring a variable, and let's say block number. And let's set it equal to a big int. So we say big.newInt, and let's pass in a number. So just say the first block, and let's go ahead and use our Ethereum client. Say client.block by number instead of header by number, and again we'll pass in a context. And we'll pass in the block number we want to get, which is, in our case, we just set it to 1. And we'll also need to add the colon here. The return value is going to be a block, as well as a possible error that we may encounter. And then we'll do a standard check again. Say if error does not equal nil, we'll log.fatal followed by unable to get block by number. And we'll just pass in the block number and the error. Let's print out the actual block. So we'll say fmt.println, and we'll say block.number, which will return the number of the block, and we'll convert it into a uint64. This needs to be block, not like that. We also forgot to import math/big, and that's why I was giving us the error on line 28. So this will go ahead and print out the block number that we queried for, which in our case should be 1. So let's go ahead and run that. Clear our screen. So this is the current block that we are getting from the previous code, and the 1 is going to be the one that we queried for here on line 28. So this block that is returned here has multiple properties. So for example, if we want to get the timestamp of that block, we can say time. And I don't think we'll need this uint. Just go ahead and run that, and you'll see that we are returned a timestamp. And let's say we want to get the difficulty of that block, we can say difficulty. Let's go ahead and run that, and we get the difficulty. Let's say we want to get the hash of that, so we say hash, and we'll have to convert that to a hexadecimal. And let's go ahead and run that, and this should return a hexadecimal hash, you can see right here. And let's say you want to get the number of transactions that are within that block. You can do that by saying block.transactions. And because block.transaction returns us an array, we can check the length of that array by encompassing that with parentheses and saying len, just like I have here. And we'll go ahead and run that. And you'll see that there are 0 transactions in this block. And what I'm going to do here is increase the block number that we're looking for, so we actually get transactions. And you'll see that this block has 107 transactions within it. Alright, so now that we've seen how we can query the Ethereum blockchain network for blocks as well as the block headers and see how many transactions are within those blocks, let's go ahead and take it a step further and see how we can actually see the transactions within the blocks. We're going to do this by using a for loop and say for every transaction within the transactions that are returned. So we'll give it a range and say block.transactions. So block.transactions is going to return us a list of transactions, which we're going to treat as a range that we use to loop through using our for loop. And for every transaction, using a FMT statement, let's print out the transaction and its data. So we can say transaction.hash. This will return the transaction hash and it's converted to a hexadecimal. When we run the application, you'll see that we are returned a list of transaction hashes for every transaction that was found within this block right here that we queried for earlier. So let's say we want to print out the value that that transaction contained. So we can say dot value, and we can convert that to a string. And let's go ahead and run it. And you'll see that for every transaction hash, there's a value. Some of them are 0 because not all transactions have value. And let's say we want to get the gas price of that transaction. We can say .gas, and we run that again. And you'll see that we are returned transaction hash, the value, and then the gas. And we can go ahead and add another print statement. And let's say you want to get the nonce. And let's say we want to get the data. And let's say you want to get the recipient of the transaction. We'll have to convert that into a hexadecimal, given that it is an address. And let's go ahead and clear our screen and run the application. All right, so we are returned the recipient. We are returned the data, if any. As you can see, there's nothing in this one. There is some data in this one. We're also returned the nonce of the sender. And we also returned the gas price of that transaction. Then we have the value of that transaction and then the transaction hash of that transaction. And that is, again, for every transaction that is contained within this block that we queried for here on line 29. Let's comment out this for loop so we don't have a lot of lines in our output. So let's say we want to get the sender of a specific transaction. So we'll have to convert the transaction into a message. And in order to do that, we'll have to get the chain ID. So let's go ahead and say chain ID. And we're also going to get possible error. And we're going to set this equal to the client.network ID, which will return the chain ID. And we'll pass it a context.background. Once we retrieve the chain ID, let's just do a quick check on the error. If error does not equal nil, we'll say log.fatal. And we'll pass it unable to get chain ID. And we'll just say fatal right here. Cool. Let's uncomment this out and we'll place this after our chain ID. And instead of printing all of this out, let's just print out the sender of the transactions. So in order to do that, we just say tx.asMessage. And what we'll do here is we'll say types.new EIP1555 signer, and that will require us to pass in a chain ID, which we identified here as chain ID line 43. So this will return to us the transaction in a message form, so we'll store that in this variable. And if there's an error encountered, again, we'll account for that. And let's check if there is an error. Say if error does not equal nil, and just say log.fatal followed by unable to convert transaction to message. And we can just do fmt.println, and we'll say message.from. And then we have to convert that into a hexadecimal because again, it is an address. All right, looks like I had an extra 5 here, so let's delete one of the 5s. We're also going to need to import the types from the Go Ethereum core package, and we also need to bring back the common package as well. And because this is my first time using the types, I will have to type in my terminal go get followed by the GitHub URL. We have not used common, so let's comment that out. Looks like we are given the sender of each transaction within a specific block. Now let's say we want to see the transaction receipts that are associated with these transactions. So let's go ahead and comment out the code that allowed us to see the sender of the transactions, and let's say receipt, and let's say error because we can encounter an error when querying for receipts. I will say client.transaction receipt, and we'll pass it a context, and we're gonna have to give it a transaction hash because that is what it uses to look up a transaction receipt. And again, because we are within this for loop, we're going to be doing this for every transaction within this block. And again, we'll do our check, and we'll just be lazy and copy and paste this, and then we'll just change this and say unable to get transaction receipt. And alternatively, we can say fmt.println or println, and we can say receipt, which will print out the receipt that we just queried for. We have an error here. Oh, context here. Oh, it's unused. We won't need this for now. Just comment it out. So here we are getting the transaction receipt using the transaction hash. And then once we get the transaction receipt, we're just going to print it out to our screen. So let's clear screen and run the application. And looks like we have to comment out this library because we don't use it. And as you can see, transaction receipts are pretty lengthy. So you'll see that every transaction receipt has a number of fields. So let's say we want to get the status of every transaction, and we can do that by simply saying receipt.status. And status is going to return 1 if it's mined successfully, or 0 if it's reverted. Oh, we don't need parentheses. Let's go ahead and clear our screen, and then we'll just run this, and you'll get a lot of these transactions were successfully mined, except for there's one that was reverted. Out of 107 transactions, there were 2 that reverted. So that was a really cool way to kind of look at every transaction receipt for every transaction. So the next thing we want to do is say, let's say you have a transaction hash and you want to look up the transaction that is associated to it on chain, and you're doing this within your decentralized application built using Go. We're also going to delete the code pertaining to blocks, and let's just keep the Ethereum connection that we have. And the first thing we want to do is essentially define the transaction hash that we want to look up, and we can do that by saying transaction hash equals common. We need to convert it from this hexadecimal that I am providing right here into a hash that Golang is friendly with. Alright, so now that we have this transaction hash that we want to query for, we can query the blockchain using the client. We can say client.transaction by hash. And this is going to return 2 values. One is the transaction itself, and the second one is an is pending flag, which is a boolean, and it's going to be true if the transaction is pending, false otherwise. So we can say if is pending. So if that statement evaluates to true, we can do a print statement and say transaction is pending, and follow it by the transaction hash. And then we still want to print the transaction hash. So we can say fmt.println followed by the transaction. And then here, we gotta uncomment this. And then, we're also missing a possible error because it can return error. And we can say if error does not equal nil, do a log fatal and pass unable to get transaction by hash. Now we can pass the transaction hash as well as the error that was produced. And then here, not enough. It's saying that, oh, we need a context, yes. Context dot background. And then we'll get rid of this math big import. Perfect, so let's go ahead and try to run this. And you'll see that we got the specific transaction that was associated with this transaction hash, and we have all the details of it here. Alright, so that was a neat way to interact with Ethereum blocks and the transactions that they contain. Thank you much for tuning in. Again, if this video was helpful or you learned something new today, make sure you give it a like, comment any thoughts that you may have, and make sure you subscribe and click on that notification bell so you are notified every time I drop a new video. I will see you in the next one.